Hi, I'm Emily Bodeau, and today I'll be talking about my project, which was on the variability of capsaicinoid content in commercially available Kashmiri peppers. To start off with some background, capsaicinoids are the class of compounds that make chili peppers spicy, and those capsaicinoids are only found naturally in chili peppers, so lots of research is being done on those compounds. Certain types of chili peppers have more or less inherent variation in the concentrations of capsaicinoids in each pepper. So what that means is while some types of peppers might have very consistent levels of capsaicinoids, others will contain much wider ranges of capsaicinoid concentrations. This variation isn't due to agronomic factors like soil or water or those kinds of environmental factors, but instead is inherent to that pepper variety. Limited research has been assessing the amount of variation in different pepper varieties, and so far what has been found is that the habanero pepper is the least variable, with a relative standard deviation of 40% and a, quote, fairly normal distribution of data. That was not computed through data analysis, but instead determined through this histogram, which does show that the habanero pepper had capsaicinoid concentrations that were approximately in a normal distribution pattern. Moving on to the goals for my research, the purpose of my study was to identify a chili pepper variety that had a low variation of capsaicinoid concentrations of each pepper for use in research on capsaicinoids. And the reason this is important for research is because those wide ranges of capsaicinoid content were coming up as a reoccurring problem for people trying to study capsaicinoids and make spicier peppers or even just study the compound. The pepper variety I chose to study was the Kashmiri pepper. So my objective was to determine if the concentration of capsaicinoids in Kashmiri peppers is less variable than the concentration of capsaicinoids in habanero peppers. I went about this by measuring the capsaicinoid concentration of 10 individual Kashmiri peppers using processes adapted from a paper. The reason why this is cited here was because the use of measuring 10 peppers was recommended as the lowest sample size that could reliably assess the variation of capsaicinoids in a pepper variety. For each individual pepper, I went about determining the capsaicinoid concentrations through a series of steps. First, I had to grind the pepper into a powder, but I did not have to dry them because I purchased them already as dried peppers. Then I moved on to isolate the capsaicinoids, which would prove to be important later. Then I measured the capsaicinoids through a chromogenic reaction, which is a reaction that produced a color. So in this case, a reagent reacted with the capsaicinoids to form a color, which can be demonstrated here on the right through these images. The left images shows how the capsaicinoid extract was clear before the reaction, but took on a blue color after the reaction. And that reaction I could then measure with a spectrophotometer. And so it was important that I isolate the capsaicinoids because other compounds in the powder of the pepper would also react with the reagent, compounds like pigments or flavonoids. So, in order to only measure the absorbance due to the capsaicinoids, I first had to isolate the capsaicinoids using a series of chemical separation and extraction techniques that were outlined in the paper I learned this process from. Moving on to my results, the concentrations of capsaicinoids were here below as followed, with the lowest on the left and the highest on the right. And I measured them at 600 nanometers for the spectrophotometer wavelength. And then here's another way of visualizing that data is through this histogram that kind of shows the more of the distribution and this frequency in several ranges. And then moving on to some data analysis, I looked at both the spread and the shape. The spread was kind of the amount of dispersion within the data set and looking at that. So we have the mean and the standard deviation And again, this relative standard deviation, and that's the standard deviation over the mean and then expressed as a percent. The reason why I chose to do this was because I want to compare to the habanero pepper eventually, and because they're in different units and because of other factors, I don't want to compare their standard deviations directly because that will be misleading. So instead, I'm looking at it relative to the mean of both data sets. And then for shape, I wanted to measure skewness to see how the peak of the data set related to the average. And then also kurtosis, which has to do with comparing the data set to a normal distribution and seeing if that peak is going to be sharper or flatter. And so seeing if like the tail ends are flatter or shorter. So like a sharp distribution compared to a kind of flatter distribution. The sample skewness showed that the data set was highly skewed left with a longer tail on the left, which matches what was found here on the histogram. And the excess kurtosis showed or suggested that the peak of the data set was higher and sharper than it would have been if the data was normally distributed. However, I ran test statistics for both of those, and they showed that no conclusions could be reliably drawn about the shape of the data set, likely because the sample size was too low. So although I included what that sample skewness and kurtosis means, there still needs to be future research to determine any conclusions about the shape of the data set. Moving on to our last slide. So my conclusion, looking at comparing the relative standard deviation, it was lower in the Kashmiri pepper by 2% than in the habanero pepper. So that shows that the Kashmiri pepper has the lowest variation of capsaicinoid concentrations out of the chili pepper types that have been tested. And then this is useful in being applied because it shows that the Kashmiri pepper is a good candidate for future research on capsaicinoids because it has those less variation in those capsaicinoid concentrations, so it can provide a consistent baseline for experiments. Since the inherent variation will be low, it will be easier to assess types of factors that can increase capsaicinoids or decrease capsaicinoids. But in the future, I do want to increase the sample size of Kashmiri peppers that I measure. This will be useful not only just because I use the bare minimum of what is useful in determining variation, but also so hopefully I can assess the shape and the distribution of capsaicinoid concentrations and determine if it follows a normal distribution or is skewed or things like that we don't know yet. And then another step that could also be done to continue this research would be to look at the variability of capsaicinoid concentrations in other chili pepper varieties, because still this has only been assessed in a few types of chili peppers. That is all. Thank you for listening.